Hi everybody, welcome to my channel, Joymon vs Code. Today we are going to look at scientific debugging. We are all developers and we might have spent a lot of time on debugging. It's very hard, right? Let us see how this technique, scientific debugging, will be helping us in finding the root cause. The scientific debugging is not something new. It is based on the scientific method, which is a proven technique in the scientific world. We'll be covering what is debugging, what are the issues we'll be facing with debugging, then debugging with a scientific debugging template. The scientific debugging is already there. That is not my contribution. My contribution is a template to document the debugging steps so that we can resume after some time, or when a new guy comes for debugging, he can also get in speed in very less time. What is debugging? As per the Wikipedia, the debugging is the process of identifying and removing errors from computer hardware or software. Basically, we are repairing the programs. The programs may be written by us or written by somebody else. It is a different skill than writing the programs. If you look at the code below, debugging is twice as hard as writing the code in the first place. That is a universally accepted fact. Therefore, if you write the code as cleverly as possible, you are by definition not smart enough to debug it. That's a quote from Brian. So basically, debugging is tough. So these are my understanding about debugging and why it is hard. It is an essential skill, but it is different. So a person may be good in coding, but will be little bad in the debugging side. The debugging process involves some context in our mind, then we validate those facts. That context include what is application, what is the purpose of the code, what are the scenarios we have already tested and verified. We lose the context when we get distracted. For example, we are debugging for 2 hours, 3 hours, then somebody calls us, maybe our boss or from our home, then we lose the context. Then we have to start over from the beginning. That's a time waste. Debugging may take more than 8 hours. Even if there is no distractions, we may be doing it for 8 hours, then we have to resume it to next day. Again, we are losing the context. It may require multiple persons. So you are doing some debugging, then you are stuck at a networking issue, then a different person would be required to debug the networking. When that person comes, we have to explain him all the things what we did, or he may ask the same things what we have already validated. Then the major thing what I have seen in the industry is trial and error debugging. People start a debugging process and touch here, do something here, there, and they're just expecting something to magically work, then understanding what is the real problem. That's the trial and error that will help us in hello world programs, but in a real program, it will be difficult to get an answer by trial and error method. Enter the scientific method for debugging. The scientific method is there for some time. Scientific community is using that method. You can get more details in Google. Just Google for scientific method. We can see that it uses an observation. Based on the observation, we can make an hypothesis. Then the hypothesis can be used for predicting outcomes. Then the predictions can be tested. The test results can be analyzed and we can refine the hypothesis. The cycle will go on till we find the right answer. So this scientific method for debugging also based on that scientific method, which is hypothesis driven. The main advantage here is like we can document our hypothesis. It will be helping us to resume the debugging process. Also, we can explain what we did to a new person who is coming to help us. Kind of applicable to any debugging, regardless it is computer science or any other problem. The scientific method for debugging is a thing which is already there. I never seen any a documentation template for hypothesis and our findings. So this video is to introduce a template I just created for documenting this debugging process. Here is a documentation template. It is in the gist using the markdown format. You can clone this template and start using it. The link to this gist is already given in the description of this video. Starting with the status, it can be either open or closed. Then we document the overview. when the issue is reported, when the issue last updated on. If it is going for some days, it is good to update last updated time. Then the environment, what are the environments this issue is happening. These are some possible values. It may happen in all the environments, or it may be in one environment, production, or it may be in staging environment. Next, the investigators, who are all the people debugging this problem. This will help a new person to understand who are all involved earlier for the same problem. Then a description, what is a issue in very simple sentence. Then the reproduction steps. Reproduction steps may not be required if we are using any ALM and application lifecycle management system where we record the defects already. There it will be holding the steps and expected result, actual result, things like that. So you can just refer that issue ID. If you are using GitHub, there will be an integer number. If it is a different application, it may be a different URL or different ID. We don't need to duplicate the same information here. Idea here is like this template should be capturing what is the issue and how to reproduce and expected and actual cells. Now coming to the observation. Here we are documenting the observation before we do any debugging. For example, somebody is reporting an issue and they are saying that in the F12 window there is a request getting failed. So those are the things which we know before we start debugging. Those informations we can add here. Then the workaround. So many issues when they are reported, the reporting person will be having a workaround, or the initial investigators may find a workaround. So that workaround can be documented here. There is no guarantee that it will be available for every problem. Just document if the workaround is available. Now start the main process, the debugging process. We can see this table has 5 columns: the hypothesis, prediction, experiment, results, and conclusion. Hypothesis is a statement we are producing based on the understanding about our observations. This need some basic knowledge about how the system works or how the system is organized. This is the main part. If the hypothesis is gone wrong, then we will not be reaching any output. Then based on hypothesis, we can predict. That prediction can be experimented and the result of the experiment can be documented here. Finally, the conclusion. So based on result, what are we concluding? So we may conclude the root cause, or we may conclude that the hypothesis is wrong or it need a refinement. So then we start with a refined hypothesis. Then this cycle goes on till we get a root cause. This is not a magic to solve all the issues. We should know some basic understanding about the system and the technology to formulate proper hypothesis. This is just to help us to document and follow an predictive process to reach root cause. Once we find the root cause, we can document the same thing here. And solution can be short term and long term. If we are near the release, we may not be able to implement the long term solution, so we can document short term as well as long term. Then the next steps based on the recommendation by the debuggers, this next step can be documented here, and this can be given to the actual development team or whoever is supposed to implement the solution. And finally, the references. So whenever we are debugging, we may Google the things. There will be some findings in Google, and our next step may be based on that URL, right? In maybe mostly in the Stack Overflow. So the link to the Stack Overflow or any other URL can be added here in the references. On a next day or after we hand over the debugging details to the development team, they may have questions and they don't want to do the Googling again. They can just go to the references here. Coming back to the debugging table. So this is a main area. It will be difficult to understand by just adding some headers. Let us look at one real example. At least I tried to debug one of my issue. This is a debugging what I have did for my own problem. The problem is very simple. I connected an external hard disk into my router, then try to access from the computer, Windows 10 computers. It is not working. Then I have to find out why the external hard disk is not visible in the computers using the SMB protocol. So currently the status is closed because I found the root cause reported on April 23rd. and it took like 1 day to find the root cause. I was not debugging like continuously. I was doing debugging like here and there whenever I get a chance. And environment here is all environment. I don't have any production or staging environment. It's just an external hard disk connected to the router. I'm the only one investigating. The description of the issue is simple, like connected an external hard disk to Optimum. Optimum is my internet provider. They provided me the router and the model name, and this issue is mainly happening in Windows 10 machines. Repression steps may look silly, but I have added that this is expected result and this is the actual result, a network error when I am trying to connect using the SMB protocol. These are the observations before I start any debugging. So I just Google for the Optimum router page. I went to the Optimum router page and it shows we can connect the hard disk, and I tried the Windows debugging network debugging dialog, and it says issues there, but issue not resolved. Workaround, there's workaround. I can connect the external hard disk directly to the computer and do the things. Instead of connecting to the router and accessing through the SMB protocol. Another workaround is I can connect the external hard disk to the computer, and from the computer I can share the folder. Then I can access from the other computer using that share. Doesn't make much sense, but it's a workaround. Coming to the debugging part, you can see that I formulated 4 hypotheses and all the results are here. Let us go one by one. The first hypothesis is router needs a restart. Based on my previous knowledge, so many things work after restarting. That is my hypothesis, and this is a prediction. If you restart, it will be solved. Experiment is restart the router. Result, issue not solved. That means the conclusion is this hypothesis has rejected. Now, second hypothesis, wrong IP of router. Normally we use 192.168.1.1 as a router IP. In case the Optimum uses a different IP, things will not work. So that is one hypothesis. So if we use the right IP, it will work. That is our prediction. So we can find out the router IP using the ipconfig command and use that IP address. I could see that the IP address is same, 192.168.1.1. That means issue has not solved. The hypothesis rejected. The next hypothesis is SMB ports. SMB protocol require some specific ports to be open between the machines. So that's the next hypothesis. The prediction is if the ports are open, it will work. Experiment will be to connect to the port using the telnet. Telnet is a software which we can use to connect to an device using the IP address and port. The result is ports are open, so hypothesis has rejected. Then the next hypothesis, Windows 10 doesn't support SMB 1.0, which used by the router. The SMB protocol has multiple versions, 1.0, 2.0. There are some security issues in SMB protocol 1.0, and Windows 10, the latest updates of Windows 10 is disabling that older protocol, 1.0 protocol. This is a knowledge we have to be aware. This doesn't come with this scientific debugging method. So if we don't know this knowledge, we will never be reaching the root cause. This knowledge can come from the Google if we know how to Google properly. So once we have this hypothesis formulated, this debugging process will help us. Back to the debugging. This is my hypothesis. This is a prediction. If we enable SMB 1.0 in the Windows 10 my computer, then it will work. So experiment is enable SMB 1.0 in the Windows 10 and test. When I enable the 1.0 SMB protocol 1.0 version, it worked. I reached the root cause. The root cause is D-Link, my router version doesn't support latest SMB version. It is just the SMB 1.0. Another supporting is Windows 10 has disabled SMB 1.0 by default from the version 1709 onwards. Current solution is enable SMB 1.0 in Windows 10. Real solution may be buy another router which support SMB 3.0. The reference I have already included in the root cause. It should have been in the references section. This is a link to Microsoft documentation. I hope you might have got a better idea how to use a scientific debugging template, reach to an guaranteed outcome in the debugging process. Also, how this can be used to transfer the debugging knowledge to a different person. Thanks for watching the channel. In case of any queries or suggestions, please add into the comment box. If you like, you can subscribe for more videos like this. Happy debugging. Bye.